Hi, welcome back.
Now let us see question number 11. So here it is said 6-point charges, each having a value q, are placed at the vertices of a regular hexagon of side A. What is the net force acting on point charge minus q placed at the center of the hexagon? So you are having 6-point charges and the value of each charge is what? Q. There is a symmetrical charge distribution, right? And all these charges are placed at the vertices of a regular hexagon. So first let us draw a regular hexagon in this particular case. This is how we can draw a regular hexagon. And it is having 6 vertices, and at the 6 vertices we are having 6 point charges of magnitude q. Okay. Now, and the side is given to you A. A is the side of the hexagon. Now you see what is the net force acting on a point charge minus q placed at the center. So at the center you can say there is a charge minus q. So what will be the net force on this charge? So as we know, when there is symmetrical charge distribution, then the net force at the center is 0. How it is 0? If you see, this force is positive. Sorry, this charge is positive, this is negative. So due to this charge, it will experience a force this side. And similarly, due to this charge, it will experience a force this side. So it will compensate. Similarly, this side, it will experience a force due to this particular charge, and on the opposite side also, so it will cancel, and for this side also it will cancel. That means these all the charges will cancel, and you can see net force is equals to 0. So directly you can do for symmetrical charges will experience net force 0 at the center. Clear? Now let us see the last question related to the Coulomb's law. So question number 12. Here it is say 2-point charges q and 2q units are kept at a distance d apart in air. So you are having two charges q and 2q, and they are at a distance d separation. And you are having a third charge q, which is to be kept along the same line, okay, in such a way that the net force acting on q and 2q is 0. So you're having third charge q, which is kept along the same line, that is the line joining the two charges. And you will have to keep these charges in such a way that q and 2q will experience 0 force. So calculate the position of charge q in terms of d. So you will have to write where you will place the charge q, so that both the charges q and 2q will experience 0 force. So for this, let us draw the figure first. So first let us write, this is your charge q. I'm placing it at the point A. This is your charge 2q placed at the point B. So in this case, if you see this side, there will be a force on A due to B, and this side there will be a force on B due to A, right? So you will have to place the charge at certain position, okay, so that it will have opposite force. Q will have this side a force and 2q will have this side a force. It's only then the force will be what? 0 on this charges. Now if you see, if you place a positive charge, okay, when you will place a positive charge, because already I have said you that whenever we are having what? Both the charges are of same nature, then we will always place charge between the them. Okay, so now if I place here in between these two charges, if I place at the point C, suppose I'm placing a charge Q. If I place a positive charge, obviously this force will be what? Repelling force. Okay, this charge will repel this charge Q, and similar this will also repel, and this force will become what? Net force will be not 0, because it is in the same direction, force will get added. So I will place a negative charge. Okay, so that when there is a negative charge, this charge will be attracted toward this. That is, this force on Q due to Q will be in this direction. And similarly, the force on the charge 2q or due to the minus q will be in this direction. This is force on 2q due to q, okay, due to q. This is how we can write. Okay, so this is the reason that net force on q and 2q will be 0 only if this particular charge is negative. All right, now we will just do the basic things. First of all, in this case, for the force to be 0, okay, on force to be 0 on charge Q. Okay. Force on the charge A due to beam. Okay, it must be equals to what? Force on charge A due to C, right? Because this charge at the point A will experience a force due to charge 2Q and due to charge Q. So all these two forces must be what? Equal. It's only then this charge Q will experience zero force. Okay. So directly we will use the Coulomb's law. It is K. Okay. A and B. At the point A you are having Q charge. At the point B you are having 2Q charge. So it is Q into 2Q by distance between these two charges is how much? This is an important thing. This distance between A and B was D. And I'm taking this distance to be X. And this distance will become what? Obviously, this distance will become D minus X. Clear? So, the distance between A and B is your D square. And here A and C. So, Q, K into it. C is what? Q, because you need only the magnitude, not the sign. And between A, C, the distance is X square. So, what you can see, this K and Q will get cancelled. This K and Q will get cancelled. And you can write from this particular equation 2Q by D square is equals to Q by X square. Okay, in turn what you can write, bring the charges on one side, you can write Q and this side you can write it as small q. It is equals to what? 2x square by D square. This is how you can write. So this is your equation 1. Similarly, you will write force on charge 2Q will be 0 when force on charge B, okay, due to what? First on B due to A, it must be equals to what? Force on B due to C. Clear? So force on B due to A must be equals to force on B due to C. So this is simple. A and B the same. K, the values are Q and 2Q and Q, and the distance is D square, right? And here you will have same Q, 2Q into with Q. The distance will change as D minus X whole square. So I'm writing K, 2Q cancel, K, 2Q cancel. And from here directly what you can write? Q by small q. Taking this Q to this side and this to be as D minus X by D square, and this is D minus X whole square. This is equation 2. So when you see in the first equation also you got capital Q by small q in the next also. Okay, so we will compare. Okay, we will compare equation 1 and 2. And what we will get, this is D minus X whole square by D square. On the other side, what it was? 2x square by D square, right? So now you see this D square and this D square will get cancelled. This will give you what? 2x square is equals to what? D minus X whole square, which you can write as, this can be written as root 2x whole square. This is D minus X whole square. Now when you will equate the powers, okay? Equating the power, what you will write? You can write root 2x is equals to D minus X. Clear? So from here, what you can write? This x and this x is there, right? So if I bring it to the other side, you can write D is equals to root 2x plus x, which can be written as D is equals to what? Root 2 plus 1 x. And you were asked to calculate the value of what? X, right? X is the distance. That is the position of the third charge. So x is equals to D by root 2 plus 1. So this is the value of x. Okay, you can write it here. X is equals to D by root 2 plus 1. So this is the value of x. That is the position of the charge q in terms of D. Clear? So you just need to see the basic key concepts, use the formula correctly, do the calculation and the simplification correctly with full focus, and you can do all the sums related to Coulomb's law. So that's all in this video. Thank you so much. Have a good day.